Hi, Michaela. Thanks for sending us in your question here. This is a three-part problem, so this might take a little time to go over. So I'd say sit back and enjoy the show. Okay, the first thing we have is our interval that they care about, which is really important. They only care about the interval 0 to 3 pi over 2. So that's the only interval we're actually going to focus on in this problem. It says find the x-intercepts. Okay, so to find the x-intercepts, you just set the function equal to 0 and solve for x. Okay, so you take out sine x, you get sine x minus 1 left over equals 0. Okay, and then what we'll do is we'll set them each equal to 0. I'm going to set this equal to 0, but I'm going to skip a step and just set it equal to 1. Okay, so the values that satisfy this, I hope you know your unit circle well, because that is going to be huge on this type of problem. So if you don't know your unit circle too well, make sure you memorize it. Make sure you study it. The value, think of sine as the y value. So the x, we're thinking of where the y value is 0. And that occurs at two places in this interval here. That occurs at 0 and pi. Okay. And then where the sine x is 1, well, that occurs at pi over 2, or 90 degrees. Okay? So those are our x-intercepts in this interval here. Okay? So the answer is part A, I guess we'll say. And now let's look at part B. It says find the intervals on which f is increasing. Okay, so we have to find the derivative. Okay? Because whenever you want to look for increasing, decreasing, you always find the derivative. So we'll take the derivative of the first guy is 2 sine x, and then I'm not sure if you remember we did a problem earlier that you have to use the chain rule. So we have to do times cosine x, because that's the derivative of sine x, minus cosine x equals 0. Okay, we take out cosine x, because they have a cosine x in common. We're left with 2 sine x minus 1. Okay, we set each one of these guys equal to 0. I'm going to solve for sine x in this one, and you'll get 1/2. Okay, and then the values that satisfy the first guy, where cosine is 0, that occurs at pi over 2 and 3 pi over 2. Okay, because cosine is the x value, and at these two angles, 90 and 270, the x value is 0. Okay, the sine is 1/2, so that's in quadrants 1 and 2, because that's where sine, or the y value, is positive. And that occurs at pi over 6 and 5 pi over 6. Okay, so now we're going to make a nice little number line from with our endpoints 0, 3 pi over 2. We would have these anyways on here, but 3 pi over 2 happens to be a critical value as well. Okay, so we're going to have pi over 6 somewhere over here, pi over 2, and 5 pi over 6. Okay, so to save some time, because this takes a lot of time actually to plug in each of these angles, or an angle inside each of these intervals, I kind of just did it on the side. So I'll let you do that for fun on your own. But here's a negative, positive, negative, and it ends up being positive here. Okay, and that's when you plug it into f prime of x, or y prime. Okay, so therefore, this function is increasing in this interval and this interval. So the answer to that one would be it's increasing in pi over 6 to pi over 2, union with 5 pi over 6 to 3 pi over 2. Alrighty, so that answers the second part. Alright, and now part C, I guess you could say, is you want to find the absolute max and absolute min. Okay, so we're going to use the closed interval method, kind of like we did in an earlier problem. And we're going to use all these critical values right here that we have found. So 0, pi over 6, pi over 2, 5 pi over 6, and 3 pi over 2. Okay, so again, I did this work on the side here. You're more than welcome to do it, but you want to plug in these values into the original function here. Okay, because we know these are potential absolute max and mins here, these values, because these are the critical values and the endpoints. 0 and 3 pi over 2 are the endpoints. And these three values are the critical values. All right, so I plugged them in into the original function. I got a 0, negative 1/4, 0, negative 1/4, and 2. Okay, so that tells us, see how 2 here is the biggest y value, so therefore this is the absolute max. Okay, and then this is kind of an interesting scenario because we have two minimum values here. Both these two give you a negative 1/4, so they're tied for the smallest value. So in this case, we actually have two absolute minimums. Okay, and you can have that. You can have more than one absolute max or absolute min. You can even have 3 or 4. Okay, so that would be the answer for part C there. Alrighty, thanks for sending us in your question, and I look forward to answering more of them.